Hello everyone, this is my next video number 18 on the topic electric machines. In my previous video, I have discussed about the concept of single phase induction motor, and I told you through the cross field theory how the single phase induction motor cannot start by its own, and hence if we want to start a single phase induction motor, we require a separate mechanism through which it can operate and it can start. You see here, to start single phase induction motor, we can put two methods, mechanical methods and electrical methods. Most of the time, you have analyzed that when your single phase induction motor, like your ceiling fan, is not working, you are giving one mechanical push to your fan and it's start running. But this method you see is not physically acceptable. Why? Because it is not possible to give mechanical force every time to start your single phase induction motor. And hence you require some electrical arrangement. This arrangement we will discuss with you in next video. In this video, I am going to discuss the another method to explain why the single phase induction motor is not self-starting. This method or this theory is known as double field revolving theory. This theory is based on the Ferrari principle. According to Ferrari's principle, a single phase can be assumed to be assumed to be split magnetic fields. These two magnetic fields provide the torque in two different directions. I think something is missing over here, so I'm explaining you, no problem. Let us say that these directions are forward direction and reverse direction, right? What this theory say? This theory say, Ferrari's principle say, that any magnetic field can be assumed that it is split into two parts. And due to these two parts, we can say that if one part is trying to rotate this in one direction, another one will try to rotate in other direction, right? As I also told you that through cross field theory, in cross field theory, I explained you in my previous video that if this positive polarity is trying to rotate in one direction, then this negative polarity is trying to rotate in opposite direction. Say this is clockwise positive direction and this anti-clockwise negative direction. As you know, the formula of slip is ns minus nr upon ns. So for this ns minus nr upon ns, I am saying this is a forward direction or clockwise direction, whatever you say, is a positive direction. And I am assuming this SF is equals to say S, right? Now, if the motor is running in opposite direction, then what you will do? You will put this NR equals to minus NR because the rotor is rotating in opposite direction, and you will get NS plus NR upon NS, right? You can write this expression like this also, 2 minus NS minus NR upon NS, right? If you take the LCM, the same thing you will get, which is written here. Now you see NS minus NR upon NS is again S slip. So you can write SR equals to 2 minus S. This means you have forward direction slip S and reverse direction slip 2 minus S. In other words, if motor is moving in positive direction, clockwise direction or forward direction, then if the slip is S, then in opposite direction you will get the slip equal to the 2 minus S. And we are saying this as a forward direction and this one is as reverse direction, right? Now suppose at standstill, you know that NR will be 0, and if NR will be 0, your slip will be what? Why? NS minus NR upon NS. So at starting, you know, the slip will be, the rotor speed will be 0. If you put NR equals to 0, you will get S equals to 1. In starting, when S is 1, you see here, SF will be 1 and SR will also be equal to 2 minus S, which is 1. From the concept of the torque equation of three-phase induction motor, you know that T is proportional to S. Means, this we have seen at the time when we were discussing the torque slip characteristic. And this is you have the case 1, 2, 3, 4, but this is the case for the operating range of the induction machine. And most of the time when we consider the operation of induction motor, we assume that motor is operating in this region where R is less than S. But the whole discussion you can refer the video in which I told you about the torque slip characteristic. This means if in starting, since forward slip and reverse slip both are same, this implies forward and reverse both torque will be same. And since you are getting the torque in both the direction equal, this means motor will not run. But if suppose by any method, maybe mechanical or electrical, if you give a push to your machine in one particular direction, and suppose I am saying you are giving a push in forward direction, and you are putting the value of S equals to 5%. 5% means 0.05. So if you are putting S equals to 0.05, then SF is equals to 0.05, but SR will be 2 minus S, which is 1.95. And you see the forward direction slip is very less compared to reverse direction slip. And therefore now these two torque will not be equal. In this case, you see the reverse direction torque will be very high comparing to the forward direction. This means now the motor will start to rotate in reverse direction. What does it mean? This simply means that in starting, when you give supply to your machine, since the forward direction slip and reverse direction slip both are equally 1, the machine will not operate. However, a supply is given to the machine, you can say a push, or you can say mechanical or external arrangement in such a way that machine is giving some torque or some force through which it starts to rotate in one particular direction. Then the slip of both the direction will be drastically changed. The difference will be very high, and hence in particular one direction the motor will start to run. So I hope this double field revolving theory is clear to you. Through this theory, we can understand that if we provide, you see the last paragraph here, if we provide an external method to rotate the rotor of single phase induction motor, this will create a difference between the slip of both the directions. As a result, motor will start to run. And hence, in next video, we will try to explain you the electrical method through which we can make our single phase induction motor self-starting. Thank you.